Good morning, followers. Good morning, members of the econometrics, applied research, and capacity building. Today's video is a continuation of our previous work on simple data analysis. The previous video we worked on data cleaning, and today's video we are purely going to focus on basic estimation of the same data. So quickly, let me just import the data that we used during our previous session. Please go back to my videos and see how we can import data to Stata. So this is the data. It's unclean. But what we did last, we used a do file where we kept our estimation commands. So let us retrieve that same do file and ensure that we follow the steps so that we clean the data before we start the estimation. So open a do file, you say file, then you say open. This was the space where it was saved, and this is the file. Excuse me. You click, and this was the do file that we developed. So without wasting time, let me just highlight all these commands to get the data clean, ready for estimation, because we've done this part of the exercise. So go back to the first video and ensure that you watch that video to see how this data was clean before the estimation. So at a glance, we just highlight all the commands, then we execute. You can see that we've done something here. At least we've cleaned the data. It's not the same the way it was uploaded to Stata. It is now clean. And one of the steps that has remained is the labeling the indicators, labeling the variables. So we further go. This was done systematically in our previous video, so go back and watch that video, cleaning and preparing simple survey data. So to label, we just highlight all of this. Then we execute. You see that we've labeled the variables. So the next step is to do basic descriptive statistics. So this is the text. We introduce the star sign so that we can convert this information to text. This is just explanation of what we are doing. So it's not a command. Sorry, this one is a command. So under basic summary statistics. So what we do here, we type the command correctly. Be aware of Stata, sensitive to uppercase. So if you include uppercase, you will not get the correct command. So we change this S, capital S, to lowercase for us to get our command right. So what you can observe here also, this indicator is in lowercase, but the variable name here is in uppercase. So we need to change that correctly before we execute our command. So age is in cap, educ is in cap as well, So you type this well. So we need a simple summary statistics of these indicators, both age and education. So we click where, in other words, we execute. When you execute, we have a summary table. The variables are age and education. The number of observations for age is 9. Then the average, in other words, the mean, is 47.667. You round it up, you have 48 years average. The standard deviation, the variation of the standard deviation around the mean, the variation around the mean is 16.228, is moderate, and the minimum age starts from 20 and the maximum age is 75. For education, which is abbreviated as EDUC, number of observation is 9, and the average level of education is 3. Then the standard deviation, the variation around the mean is 4.24, it's moderate, and the minimum level of education is 0, which means we have respondents that have no education or just have pre-educational level, and this is university level or higher education. So it ranges from 0 to 10. So this is just a basic statistical classification of this variable or this output. So next thing we may want to do, or want to know the frequency of these indicators for both sex and that of education. So we type the variable correctly, as you can see here. Then we have a duke. It is in cap. So we say a duke. What we want to do, let us just, once you have the indicator or the command correct, you can just alight and execute. When you are using do file, you can do this at once. So let us see the frequency of these indicators for sex and that of education. So for sex, both male and female, we have number of respondents for female is 3, representing 33.33%. After counting for female, the accumulated frequency is 33.33%. Then the number of respondents for male, the frequency is 9 here, representing 66.667%. After adding male to the previous cumulative frequency, we have a total frequency of 100. So in total, the number of respondents is 9, representing 100%. So here we have 9 female and 6 male on the sex category. For education, we have level of education 0, grade 0, grade 7, and 10. 0 usually tells you that implies that the sample or the total sample, we have 5 respondents that have no education or have a pre-educational level. We have 2 individuals or respondents that have a grade 7 level of education, and we have 1 person who is at university. So for grade 0, representing 5%, 5 frequency, 5 respondents, representing 62.50%. For grade 7, we have 2 individuals that have a secondary level of education, representing 25%. Then we have 1 respondent having higher education, at university level with representing 12.50%. So the total number of observations is 8. So you can copy this table and send it to your Word document, or you design it well first in Excel, then you transfer it to your Word document to do your analysis if you are dealing with real data for your study. So this one is very important. So the next step that we need to do here, we need to do a cross tabulation, or want to know the relationship between sex and education. Sex and education. So this is a text. We introduce our star. So the command is tabulate sex. Let us type the variable well. And educ is capitalized. So let us see the relationship between sex and education. So we execute. This is the same output. The only thing that is unique about this, it brings you the indicators in a single table that is very easy to do a comparative analysis instead of generating a single table. So for gender group, we have female and male, and the column here we have the level of education, starting from 0, 7, 7, and 10. So these are the indicators and the characteristics of their values. We have female, male, and that of the output in terms of frequency. So for female, we have 3 respondents that have no level of education or have pre-primary school level of education, and we have no respondents for grade 7 level of education and no respondents for grade 10 level of education. So total number of respondents is 3 for female. Then for male, we have 2 individuals that have no level of education. Then 2 we have 2 that have grade 7 level of education, and only 1 respondent that has high level of education at university level. So total number of respondents in this gender category is 5. So under grade 0 level of education, the total number of observation is 5. Then 7 we have 2. Then 10 we have. So this is just a simple interpretation of this output. If you are running a simple or survey data, it's the same approach if you are using large data. This is just a simple survey data. So the next step here is what we do next. We want to know the mean age by gender. The mean age by gender. So this is what actually we want to do. So we'll convert it to text. Readers of this do fight to know that the next step here we want to get mean age by gender. So this is the first command. You highlight. Sorry, the age is in cap, so make sure that you capitalize that. So when we execute and see what comes out of it, sorry, sex should be in cap, so we'll not get the correct command. So let us execute and see what comes out of it. So we've got the mean age. by sex. For female, the average for female number of observation, we have 3 individuals with average age of 60 years with a standard deviation 18.57. This shows a kind of high variation, and the minimum age is 39 years and the maximum age is 75 years. For male group, we have 6 respondents or individuals in the sample size of 9. Then we have average age of 42 years, a moderate standard deviation of 12.5. Then the minimum age is 20 years and the maximum age is 55 years. So here we have a female respondents older than male respondents if you want to do further analysis. So further, you can also copy this table and send them to Word. But for me, I usually take this to Excel. I design it well before I send it to Word for analysis. So the next step here is what it is the same thing, but what we are going to see here is the same command, but what we are going to see here, we see that we bring the statistical analysis in one table at glance that will help us to do our analysis. So we have age. This has to be type 12. Age, sex variable, then let us execute this command and see what comes out. So it is the same output, but the initial one gives us an individual output of the gender category. But this one brings things in at a glance that you can do a simple summary that can make your analysis simple or makes it very easy to visualize your output. So gender category for female and male. For female, we have an average age of 60 years is the same output with high variation 18.6. Minimum age is 39 and maximum age is 75. For male, the average age is 42 and the standard deviation, the variation around the mean is 12.5, is moderate, and the minimum age is 20 and the maximum age is 55. In total, average of age is 48 years. Then the total standard deviation is 16.28. Then the minimum age in total is 20 and the maximum age is 75. So that is simple interpretation of this output. So the next step here is to ensure that we also create a relationship between education and age using correlation. Using correlation in this category, then we have educ. Educ stands for education, is the coding for education. Then we execute and see what happens out of this. So this is a correlation. Correlation actually shows that the two variables move together. But the weakness of this command does not tell you which variable that influence the order. So in other words, correlation does not provide information information about which variable that actually influences the order. So correlation does not mean causation. So that's a simple way I can put it. So the coefficient here is negative, tells you that increase in education increase in age reduces education. And the relationship is it's a bit weak. It's not too strong. It's roughly 35%. So there is an inverse relationship. As age increases, education reduces. It sounds well, but might not be that it is age actually influencing the, the, the is only the influencing factor of this variable, influencing factor of education. You may have in terms of accessibility, you have poverty issues. These are all a total factor and other factor or social factors that might affect level of education. Doesn't necessarily mean that it is age that's affecting education. So it is important to aware of that when doing your interpretation. So we want to do a graphical representation of this same data. We want to see how histogram can present this data. We want to see age. So type age correctly as it is using histogram. Also gives you that same information. The only thing, this is presented in graphical form. So let us see what comes out of it. So this gives us age distribution. You may want to edit this. You may want to edit this, giving it a title. We call it age distribution. Age distribution, you say, okay. If you want to know how to edit graphs, my first video gave you a step-by-step tutorial guide as how to edit your graph. So I encourage followers or members of this econometrics applied research and capacity building to go back to that video or go through my channel and see that you'll be able to get the basics. It's very important. Also, you may want to give a different color of the same histogram. You right click, you go to observation properties. You may want to give it a different color. Emerald. I like emerald just to differentiate. You can choose your own color. Observation property. You may want to give it rose just to make the output look somehow visible. To see the outputs of the histogram visible, you may want to also give this a color, as the case may be. Instead of black, you give it may give it green, as the case may be. So you see that the distribution here ranges from 20 years to roughly 75 years. So a greater number of the participants or the respondents in this survey fall between 40 to 60 years, and we have less participants or respondents falling in the group of 20 to 40 years younger age. This is the middle age, and the old age is also similar to younger age, or the Gen Zs fall between 60 to 70. So you can also copy this table if you feel like. doing an interpretation of it, you copy and send it to your Word document, and you do your analysis. I think you may want to also see this same output in terms of bar charts, having seen the histogram output. You type the variable the way it should. You type sex with the initial letter. You alight, then you execute. Let us see also what comes out in terms of bar chart, showing mean age for female and male. You may want to call it mean age. You edit. Edit this graph so that we have a title for it. You may want to give it a title. Yes, it is editable. So you give it a title, you say mean age. You give it mean age. You can also give it a color. Give it green. You give it green. So my brother is assisting me here to have effective power supply. We'll give it green because initially we've started with green just for consistency sake. Give it green color again for this output. Then you may also want to change the color of the bars to give it a kind of different output. You give it emerald. You say okay. So you see that the mean age is 60 years from female, and for male is roughly 42 years. The same data, but what we've done here, instead of presenting it using table, we use graphs to present all of this. So it makes it very simple for you also to do your interpretation using the graph. It's very important. So we close this. We don't need it. For those that want to copy and send to Word, do analysis, or you may want to send to me to look at it, whether you've done the correct thing. You can also copy if you want to do exercise and paste. You send your analysis to my email. We may want to get a simple regression. It's not a simple regression, it's a multiple linear regression model because it has more than one predictor or independent variable. So what we do here, we type education variable. It is the dependent variable. We type age, then sex. We type it the way we've renamed it, capital letter SEX. So we run a multiple linear regression model with this and see what comes out. We alight, then we click. This is a multiple linear regression model. Just for purpose of practice, because as it is, this model is not significant. If you can see the p-value is greater than 5%, is 35%. So it's like it's not a suitable model for estimation. And even the R square, as you can see, is 35%. Even when it's adjusted, the adjusted R square is 8%. So it's not a suitable variable for policy implementation. And you can prove that when it comes to the coefficients, you see that we have output for coefficient, but the final analysis here is all of the indicators or the coefficients of the indicators are not significant. As you can see for age, it is far away above um, the statistical significance level. It's almost 97%. So it's not significant. It's not suitable for policy implication. As well as for sex, it's the same thing, is not significant. But for the purpose of practice, it is important to know that if you are doing a survey data or survey studies, you may want to produce simple OLS or multiple linear regression OLS. This is the same command, say regress, and you indicate your dependent variable followed by the independent variable. You click or you execute, you will get the output, then you do your interpretation. I think the next video will make sure that we'll come with data that can show some kind of positive result that's suitable for policy implementation. So this is for purpose of training. So we are just introducing you. So if, for instance, you are running a survey data, you run a linear model and you have outputs of this, the variables are not significant, the p-value is away from the threshold significant level, it's not significant at 1%, 5%, even at 10%. So it's like it tells you that your model is not suitable for policy implication. So you find way to address that. For this, the problem might be because the sample size is very small. We only have 9 respondents. So the population here is just a total of 9. So we'll not be able to get a correct result. But for the purpose of learning, it is good also to understand this, while we look for data that will help us to have a positive result for policy implementation. So, ladies and gentlemen, thank you very much for your participation and your support to this channel. Continue to watch these videos, you share with friends, and also at the same time you can subscribe, you do your comments, you send your suggestion to our email so that we'll keep this platform going. Thank you very much. Please continue to join me. The next video will be a continuation of the same work on simple survey data, but we are going to work on how to generate age groups. So continue to follow up so that you can get my videos as I produce them time to time. Thank you very much, followers. Thank you very much, members of this channel.